On number 2, we are to write the sum in standard form. Good news here, basically this is a pre-algebra problem if you just think of it as combining like terms. So we're going to combine 2 and 3, our real parts, so 2 plus 3 is 5, simple enough. Then we're going to combine our imaginary numbers, minus 3i and minus 4i into minus 7i, just like terms, nothing to it. When we subtract, the only suggestion I would make is that you distribute the minus, which in essence changes the sign of each thing inside. And then it's an addition problem just like the first one we did. The only thing here is you have to be careful because they wrote the second number in non-standard form by reversing the real and imaginary numbers. So 2 plus 3, again, by coincidence, we have 5. And then positive 1i, negative 9i. When I add those together, I get minus 8i. And I'm done with that one. Number 12, we're going to multiply a pair of complex numbers and write our answer in standard form. And again, you can think of this as foiling. So basically we've gone from pre-algebra to algebra 1 here. 5i times 2i is 10i squared. And then 5i times 1 is 5i. Minus 3 times 2i is minus 6i. Minus 3 times 1 is not plus, minus 3. We would be done except for the fact this is not standard form. And remember that I squared is negative 1. So 10i squared is really just negative 10. And then when we combine our two imaginary numbers here, we get minus I. And then we have minus 3. So then one last step, combine our real parts. We get negative 10 minus 3 is negative 13 minus I. And that's our answer. Number 18, super simple here. We're to write this as BI. And remember, when you're taking the square root of a product, you can take the square root of each piece separately. So we're going to rewrite this first as 25 times negative 1. And I switched the order just because now, when I take the square root of each piece, I will have my answer because the square root of 25 is 5. Let's try that again. 5. And the square root of negative 1 is I. And that's the answer. 28 is a little scarier looking, but it's really not bad. So we will first take a look at this in its expanded form like this. So if you haven't already rewritten yours this way, you might want to pause the video and write it out like this and then come back. Then when you come back, we will be beginning by, in essence, foiling out this first pair. The square root of 3/2 squared is 3/4. And then the square root of 3/2 times 1/2 I is plus the square root of 3 over 4 I. And then we multiply our inside terms, so it's 1/2 I times the square root of 3 over 2, which is the square root of 3 over 4 I. And then when you multiply 1/2 I times 1/2 I, it's in essence squaring the two, and 1/2 squared is 1/4, and then that's I squared. Well, then we got to bring this other guy down that we haven't multiplied in yet. Come back, and now we'll clean up this first product that we got, and you'll notice we have 3/4, and then at the end we have this plus, sorry about that, let's get that off of there, plus 1/4 I squared. I squared is negative 1, so that's just minus 1/4, so what I really have is 3/4 minus 1/4, which would be 2/4, which reduces to 1/2. And then when I add my two I terms, I have the square root of 3 over 4 plus the square root of 3 over 4, which would be plus the square root of 3 over 2i. And then we bring our, sorry about that, we bring our one last factor back in that we had not yet brought into the product, and then we'll have our answer. Let's move where we can focus on this part. And 1/2 times the square root of 3 over 2 is the square root of 3 over 4. And then 1/2 times 1/2 I is 1/4 I. And then the square root of 3 over 2i times the square root of 3 over 2 is plus 3 over 4i. And then the square root of 3 over 2i times 1/2 I is the square root of 3 over 4i squared. Then, let's slide up a little bit, and we're going to combine like terms here. And I have a 1/4 I and a 3/4 I, which together gives me plus I. And then over here I have this plus square root of 3 over 4i squared, which is the square root of 3 over 4 times -1, so that's really subtracting the square root of 3 over 4. So basically this term and this term cancel each other out and give me 0 plus I, which would be the very standard form version of the answer, but it's completely fine if you go straight to I as your answer as well. Next on our list, I'm going to go back up here and find the problem. I've been sliding my screen around. Number 32 tells us that we are to find the product of this complex number and its conjugate. Well, remember, the conjugate is simply the same pair of terms, but you change the sign of since this is a difference, then its conjugate is going to be the sum of these two terms, is what I'm trying to say, and not doing a very good job. Alright, so here we go again. We've set it up to where we, in essence, will be foiling. -1 times -1 is 1. -1 times the square root of 2i is minus the square root of 2i. Let's try that again. 2i. And then the negative square root of 2i times -1 is plus the square root. Okay, me and my pen are not talking very well right now. Try that again. That's what we get. And then minus the square root of 2i times plus the square root of 2i is minus 2i squared. Well, in case you didn't think about it while I was saying it the first time, you notice that what happened with our I terms here is that we had opposites. And so we get 1 minus 2, and remember that I squared is -1, so really this is 1 plus 2, which is 3 as our final answer. I'd like to show you another way to do this problem, just because of the fact that the way I did it the first time is really not the ideal way. So I'm going to slide down and redo this problem the way I would really like to see you do it. So we started off with this complex number, and we were told to multiply by its conjugate. And remember, the only difference between a complex number and its conjugate is that if one is minus, the other is plus, if you will. Alright, well, what I would like for you to notice here is that this is a minus b for the first complex number times a plus b for the second complex number, which in essence allows us to square a, because remember, the result is a squared minus b squared, which we're about to write. So that's -1 times -1, which is +1. And then minus, because that's what the pattern tells us. And if I square the square root of 2i, the square root squared is 2, I squared is -1, so that makes -2, which gives me 3. A much more efficient way to do it. On to the next one. Sorry about that. Gotta find it first. Here we go. There's number 36. Write the expression in standard form. Anytime you have a complex number or an imaginary number in the quotient, you should probably get rid of that first. So what we're going to do, in fact, let me not equals, let's go ahead and just multiply right on top of it, if it'll let me. We're going to multiply the top and the bottom by 3i. Okay, when we do that, we're going to get, when I distribute the 3i across the top, I'm going to get 6i plus 3i squared, and on the bottom, I'm going to get 9i squared. Well, at first it looks like I made what's an ugly problem uglier. But in essence, if you remember, every time I squared comes up, that's happy day because you're getting rid of I in the next step. You're going to have 6I, let's try that again, 6I, and then minus 3 over, again, on the bottom we have I squared, which just makes my 9 negative because it's a -1 multiplier. Well, those numbers are all 3 factors of 3, so I'm going to reduce by a factor of 3. Probably, maybe an easier way for you to think about it would be to have, like we did on an earlier problem, divide through by that, whatever that thing is on the bottom. And then we have plus, in essence, -3 over -9. Either way you think of it, then we can reduce term by term. If I reduce by a factor of 6, I get 2I over 3 on the first one, and it was negative, so I'm going to keep it negative. And then the negatives cancel on my second term, and I get plus 1/3. But remember, to be in truly standard form, we should have the constant first. So that's going to be 1/3 minus, what that was, I do not know, 2/3 I. There's my answer. Glitches and all. Almost to the end. We're going to move on to number 38 now. This one's a little uglier, takes a little more work, so bear with me on this one. The first thing we will do is to foil out the top. So I'm going to do a little implied arrow here and do a little scratch work before I put it all back together. So I'm going to foil the top first, which would give me 2. And then when I multiply 2 times 2I, I get 4I. And then for my inner pair, I get minus I. And then for my last terms multiplied, I get minus 2I squared, which is 2. And then when I combine my I terms, plus 3I. And remember, I squared changes the sign of whatever it's attached to, so this is plus 2. So now I know the top is really 4 plus 3I. I'll go ahead and stick the bottom under it. And we'll slide over here where we can do some more work on that. And so remember, if you have a complex or imaginary number on the bottom, so in essence any number with an imaginary part, you want to do this. You're going to get rid of it, and to get rid of a truly complex number which has both the real and imaginary parts, you multiply by its conjugate. So that would be 5 minus 2I, and you multiply it by top and bottom, so we are in essence multiplying by 1, which is completely legal. So now, when we do that, we're going to get, see if I have enough room over here to go here, and foil out the top. 4 times 5 is 20. 4 times minus 2I is minus 8I. 3I times 5 is plus 15I. And then 3I times negative 2I is negative 6I squared over, now let's do the same with the bottom, but remember now, let's take advantage of the fact that this is A plus B times A minus B, so we're going to get A squared minus B squared. Let me see if I can get that a little neater for you. A squared minus B squared is what's going to go on the bottom. So if I square 5, I get 25. If I square 2I, I'm going to get 4I squared on the bottom. Alright, so now let's clean that up and we'll have our answer. So on the top, I've got 20, and then minus I plus 15I is plus 7I. And then the minus 6I squared, remember, is really just plus 6 over, on the bottom we have 25, actually plus 4 because that's an I squared again. That's going to change the sign of what it's attached to. And so we have 20 plus 6 is 26 plus 7I over 29. And then to go to standard form, which is what we were instructed to do, we simply distribute whatever's on the bottom through division, and we get 26 over 29 plus 7 over 29i. We've got all but one of our examples done. If I put a box around that for you. On to the next one. And our final one really is an Algebra 2 problem, but you'll probably have a more sophisticated appreciation of what's about to happen. So, first step to solving any quadratic is to get all the terms on one side, unless you're going to complete the square, which we're not. Although you could, so if you wanted to, I'm okay with that too. But I'm going to use the quadratic formula because I've done a whole lot less of that with you guys. Alright, so I've got an x term, and then I'm going to subtract that 5x, which would give me minus 4x. And then I've got 11, and I would add that 8 over, so I get 19 over here. So this is what we've got. So our a is 1, b is negative 4, and c is 19. Excuse me. So then we get x equals, from the quadratic formula, negative b, which would be positive 4, plus or minus the square root of b squared would be 16, minus 4 from the quadratic formula, times 1, which is our a, and then I'm going to extend my bar there, times c, which is 19, all over 2a. Well, our a is 1, so that's just 2. Well then, clean up our discriminant on the inside there. And 16 minus 4 times 1 times 19. 4 times 1 times 19 is 76, so when I subtract that from 16, I get negative 60. So then, keep everything else. Let's focus on that square root of negative 60. And remember, I can break that out, and let's remember that when we simplify a radical, we can write it as a product. So that's, I'm going to take any square I can get out of it, and I can take 4 out of that, which would be 4 times 15 times our negative 1. I haven't forgotten about that. Well, then I can take the square root of each piece separately, which would be 2 square root of 15i, right? Well, I'm going to recommend that you always write your radical last when you have exact form, so we'll save that for last and write 2i on the square root of 15 here. Well, then we've got a 2 that will distribute to each thing on the top. 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, so that means that all I have left for my imaginary part is the square root of 15 over here, and that is my final answer of our final example.